The new 300 GMS, we've also redesigned what we call an advanced operator interface. This adds a great deal of functionality to gear metrology. It shows the displacement of the X, Y, and Z axes, the displacement of the probe itself. There are several quick buttons located in the center of the screen. For instance, on the top left-hand side, you'll see the icon that says Gleason Connect. That would allow you to go, if you have an internet connection, directly to our support facility in Dayton, Ohio. It can also be used as a secondary monitor. So if you're collecting data on SPC, it's basically a monitor extension where you could have your control charts positioned on this monitor separately. It also contains a still and video camera, where if I take a picture of the part as it's mounted on the machine, the operator, when he calls up the part program, gets visual confirmation of what the probe configuration should be, what the work holding looks like, as well as what the part should be positioned in the tooling. The Gleason Connect button, as I mentioned previously, allows you to tie directly to our field support facility. The still pictures, again, can be embedded in the part program. We also use the camera as part of the Gleason Connect strategy to be able to see the machine operation. So if there are issues with the machine, we can see it live from our office in Dayton. There's a microphone contained in the box as well, so it's a complete telephony device. So the operator does not need to have a phone or a cell phone available. He can actually talk right through the machine to our support people. There's a notepad application, a calculator application for quick jotting down and calculation of gear parameters. There's also the environmental monitoring capability where we will measure the machine temperature, the ambient temperature, and can warn the operator if a significant change in temperature occurs. Due to the smaller size of the control cabinet, it contains significantly less wiring, as I stated previously. The reduction is about 35%. The connection and failure points that are traditional with these control systems has been reduced. It's reduced the overall footprint of the machine. The picture on the right actually shows the drives and the termination points. We have also removed the PC from the control cabinet, and that's now stored in the bottom of the storage cabinet. The 300 GMS also supports an automatic probe change system. In introducing this probe head, the SP25 is a full 3D scanning probe from Renishaw, available in all local markets. It has plus or minus a half a millimeter travel in all directions and up to 2 millimeters of over travel, so probe crashes should be non-existent on this particular machine. We operate this probe at a 0.05 micron resolution. Standard configuration for the automatic probe change is 6 positions. It is expandable up to 9, but that is probe configuration dependent. So depending on the amount of down legs, for instance, for internal gears, you may have limitations on the exact number that may be able to fit in the calibration or in the storage rack. All the probe calibration data is retained in a part library. The probe calibration file can be either set up as use or time-based. So for instance, a 1 millimeter probe that might be a very common size for measuring a broad spectrum of gears, you would have that more on a use base rather than a time base. But for instance, if you had a 5 millimeter styli that may not be so common, that may be set up as maybe periodically on a 30-day cycle that it would be calibrated. Probe change or probe calibration is not required at every probe change. The probes, based on your calibration cycle that you set, is retained in memory all the time with all of the actual part program files. We support multiple calibration styles, a quick 5-point measurement to do a very quick, instantaneous probe calibration and table center location, as well as a full hemispherical scan of the ball to better define the actual probe size. We have performed significant testing on the SP25. Right now we are at over 500,000 inspection cycles. Quite confident in the performance of this probe. The first chart that I'm showing here is the previous model that we used was the SP80H from Renaissance. And based on the gear parameters that we measured, the amount of repeatability over a long-term cycle study. In comparison, the same parameters measured with the SP25, and we're quite confident that this probe is equal to or better than for cylindrical gear metrology. For spiral bevel gear metrology, again, the same results were experienced. One unique innovation that we've added to this machine is the ability to measure surface finish directly with the SP25 probe. There is no intermediate electronic devices. We take the direct signal off of the probe and are able to run it into our analysis software that is embedded in our Gamma suite of applications. So if surface finish is a demand item for your company, this can be measured subsequent to the standard lead, involute, and index inspection, where we would go out and measure various locations on the gear tooth, on multiple teeth, and then take the average of those as the resultant surface finish data. And this chart will appear on screen so the operator gets virtually instantaneous feedback. We introduced Gamma 3.0 with the introduction of the 300 GMS. It's a family or suite of software that is a native Windows application. It's fully Windows compatible. Both the controls as well as the application are native Windows based. With Gamma 3.0, you no longer need to complete the inspection cycle to see typical gear characteristics like form error, lead error, slope error that can be viewed instantaneously by clicking on the chart, and the values will actually come up as you're measuring. There's a cycle progress indicator bar so the operator can look at a glance and know how far he is into the complete measuring cycle. There's a new improved graphical interface, as I've mentioned earlier, with the tooltips that allows pictorial support for gear knowledge. We know that gear inspection operators oftentimes do not have great gear depth knowledge, so we've included a lot of tools to help support their understanding of the actual feature that they're measuring. Easily networkable, because it's Windows based, all of our machines can be directly tied into most factory data management systems. New for this machine and this series of software also is the ability to program a part through QR codes. There's an application that allows you to generate a QR code or barcode that could be printed on the router. So if a new part is introduced to the floor, the operator doesn't even need to go into the software to write the program. He can simply scan the barcode or the QR code from the operator interface, advanced operator interface, and will automatically write the program. The only intervention that the operator needs to have is to go in and set up the safety distance and the approach heights to the gear as it's mounted in its work holding. All documentation out of our product is electronic. All of our charts are native PDF format, or they can also be saved in SVG or scalable vector graphics. This is kind of unique in that it's an HTML-based language, so there is no special software required to open or view these charts. Any web browser will be able to pop the chart open and they can be viewed. SVG is also a very small file, so if I'm emailing data or transmitting data electronically, I can load several files into one transmission versus a PDF file, which typically are quite large. A typical 3 4-page document can be as much with graphics on it as 2 meg, where the same file might be 200 kilobytes for a SVG file. New for the Gamma 3.0 is contact pattern and transmission error analysis. This is in an unloaded state. It is an optional model, but it allows you to take a topographical measurement of 2 mating gears and then superimpose the line of action and mesh electronically. Again, as I said previously, the fine pitch measurement down now to 0.2 module or 127 dp, and then the ability to do surface finish directly with the SP25 probe. New, just being introduced in March, is the ability to do concurrent part programming and machine operation at the same time. We've decoupled the programming database from the running application for inspection, so no longer does the operator need to have the machine or computer sitting idle while the gear inspection is being conducted. He can actually be on the computer writing additional part programming or editing part programs while gear inspection is being conducted. This graphic is the interface, the standard operator interface as it's laid out in Gamma. Across the top, you see what we call quick buttons. Those are accessed either by a mouse click, the F buttons on the top, or the function buttons across the top of the computer screen. They're the most commonly used functions in the program, so whether it's to call up a part, start a new part, abort a part program, calibrate a probe. Down the left-hand side, you'll see all the gear data, and if that's on the slide bar, if you were to move that down, you would also see all the test data that we expect to perform. There is the inserted graphic that gives the operator visual confirmation of what the part should look like loaded in the machine. Then for the expanded gear parameters, for instance, for lead angle error, that type of thing, you can see that they're displayed automatically when I explode that window and updated in real time. On the right-hand side, you see an insert of the tooltip. So when I hover over a particular gear parameter, the knowledge is built into the program that gives the operator a quick pictorial of what the actual feature is being measured. The contact pattern analysis is quite simple to operate. You basically go in and select the flank of the 2 mating gears, load the analysis, fill out a few basic parameters as far as what's the loaded side, the center distance, axial offset, resolution in the face, resolution in profile, film thickness, and then hit the Analyze button, and the calculation is made. So you'll see in the graphic here the actual ease off of the topography, the line of contact calculated, and where the contact pattern lays in the chart. We also, again, analyze for transmission error. So this is actually the power loss as the gear goes through mesh. This picture is of a 0.2 module gear being measured on the GMS with a 0.15 module probe, or 0.15 diameter, stylus. We have these down to this size. Gears below that we quote on application. Also new for the Gamma 3.0 is the ability to do full GD&T or CMM type measurements. We have partnered with a company called Applied Automation Technology that has a program called CAPS DEMIS that is a full CAD-based CMM package. Many of the manufacturers are coming to us and saying, we want the machines to do more. So since the gear is already set up to be inspected, we can measure all of the non-gear geometry that's part of the inspection of the normal part. So things like diameters, lengths, angles, and then general relationships like flatness, parallelism can also be graphically displayed. It's a great graphical reporting tool. So if you think about just a simple diameter measurement there are a significant amount of calculations that go into a diameter. So this graphic here shows a maximum circumscribed, average size of the circle, or maximum inscribed. So depending on the form, fit, and function of the part, we can analyze for several different parameters. We also support all of the world's industrial standards for gear metrology, so from AGMA to DIN to GHOST to UNI. We basically cover all industrial standards in our product family. We also support all different styles of gear, whether it's cylindrical, spiral bevel, several different styles of cutting tools, and then non-gear or parallel axis applications such as scrolls, worms, helical rotors, variable ratio steering gears, virtually any symmetrically rotational workpiece. Your investment with Gleason is a safe investment. We offer a very small footprint overall on our product family, depending on the size of the window, of the part needing to be measured. The new gamma